Hello everyone, and today I want to presentations my assignment for is advanced regression technique and using the prediction house price data set. So for that, I have the three part. The first one is model performing, and second one is stacking model, and the third one is the plus one is fixture selection. So I will take more time talking about the fixture selection, how I do and how I find it. Okay, and the first one is model performance, and I use the individual model like decision tree, gradient boosting, linear regression, random forest, and SVR, and that is the published score. Yeah, that's kind of not very good, but I'm spent a lot of time uh like turning a lot of parameter and is yeah, that is the best one. So my stacking model is the 0.23. And for me, in this time, my pre-work is first need to process missing data because missing data is ensure accurate model, like avoid bias and maintain data quality for reliable prediction. So I just like to keep in the missing ratio is less than 50% and make them visualization. So visualization you can see in the next page, but I want to talk about how I do it. So I like divide to the two data set. The first is attribute data, and second one is continued data. And if I found it that is attribute data, I will put on the none, put on the zero on that. And if that is the continued data, I will put on the mean. Yeah, because I think if that is the continued data, we put on the mean, they can make sure that our prediction wouldn't have a lot of zero and make them like to uh, underrating above our data set. So finally, we found out that the year built that have the zero point 0.3 like in the missing data point, and the second one is overall quality, and the third one is the live area. So we will just select which one is our need. If they less than the 50% of data set, we just remove it. So after that, we would do the label encoder, and a label encoder is like to help us to convert the categorical data into the numerical formats and helping machine learning model interpret and process numeric feature, and but it is only suitable for like the older or like unbiased category data. So like me, I just put on the label encoded to make sure that then that just the word or anything like the attribute data, we can make sure that can encode in like the zero and one, and to make the computer to understand which kind of data we want to predict. Yeah, and then I use the genetic feature. And genetic feature, I just want to simply introduce that one. Genetic feature is how it's like to find out the range and use the range to find out the small range and use that small range to find out the little small range. How is to find out what kind of data we want to, what kind of, I'm sorry, what kind of feature we want to use it because in my data set, there are a lot of like over 50, I think 50 feature on that. So if I just put on all features in my algorithm in my model, they would couldn't like find out the like accurately one. So I just use this genetic feature to help us to find out the gray feature and make me have a gray accurately. But I will talk all of three of feature selection in the last page. Yeah, last section, sorry. So I want to talk about the stacking model, and I use this five stacking model like Synergy SVR, random forest, linear regression, and as yeah, and that one is make me think about that. Yeah, that one is gradient boosting. Yeah, I forgot it. Yeah, so that's for me. I put on the five model to help us to find out to build stacking model. After that, I used to turning their hyperparameter and use the estimator to from 50 to 200 and learn rate from 0.01 to 0.2 and max depth I think just 3 to 5 because in the past I always think that max depth uh, didn't affect our predict results. Yeah, in the past assignment, so I just put 3 and 5, and I got the best one is learning rate is 0.1 and max depth is 3 and estimator is 100. So yeah, that's the great one. So I just want to do some data visualization to make people, make professors and TA to more understand my model performance. Like the linear regression, I got the AUC 0.994, and that's the second grade one for individual. The first one is gradient boosting higher than 0.93, and in the QQ plot, I think that is I don't think that it can say is very correlations, but that is can help us to predict our texting data as well. So I think that is the great data for me. And the third one, I want to talk more about the feature selection because the feature selection can help us to get off the great feature. And we didn't, if I have the practical work, I need to like to so restore like over 100 feature, and that is not make sense of if we want to do some prediction, we want to do some prediction modeling algorithm, we must be use like the feature selections to help us to rapidly find out which features we want to use it. So for the feature selection, I put on to the calculator, it give me the 0.20 that public scored. And in the feature selection, the first one I used the select from model, so it can be a lot of like the features can make us to understand what kind of feature is that selection from model help us to find out is like more highly related to our model or our data set. And the second one, I used the sequential feature selector to help us. Yeah, that's very great. That's excellent because it gives me a very small feature to help us to more understand which kind of features we want to use this. And so the first one is select from model, and the second one is sequential feature selector. And the last one is a genetic selection. Yeah, the genetic selection is which one I used this before, but I just want to take and try again to use more like the parameter to help us to like find very accurate feature for us. But I think that have the difficult one is if I select like I use very uh process I use a lot of like parameter that will make us to find a lot of feature because it's kind of like we put on a lot of parameter and they will think, oh yeah, that is related to our feature. The other one is related our feature as well because we have a lot of like the selections can they can put make them to think about, yeah, that is related to our correlation. So for me, I put on sorry. I put on that free feature selection and to help us to uh, combine with together and to find out which one is that three feature selection have presence. So I will put on that sure feature and to my final feature. So in that picture, yeah, that is final selection. What I say, I used the interact intersection of the pictures to select by the all three method. So even my genetic selection get a lot of pictures uh to my finals. But I think if I put on the three one, yeah, you can see the pink one. The pink one the three one they have some overlap, so I choose that over that picture to help us to find out the accurately accurately picture. So in the final, because I do the two different Python, because I just want to make sure that the three feature selections can like give me the very personal information, so I put separately. So for this Python coding, I found it that if I use that three and to make them the intersection, just only that variable, and I got the gradient boosting AUC's got the 0.99 linear regression and got the 0.98. But is very cool is that the random forest is got AUC one. So I think it's kind of like the overfitting point. So must be like if we use this feature selection in our algorithm, make sure that we must be to avoid overfitting in our like exploration or anything like. But the static model have the grade as well. So that is my presentation. I hope you guys like it. And I want to make sure of that because in the last time I did that, I put on my Kaggle score, but I didn't get it great. So I make sure this time I can get it. I put on in my video and in my PowerPoint, make sure that I can have the point. I can get the grade and didn't will be mentioned that I lost or missing data. And I have the feature selection point. I make sure that I just wish make sure that I can get a more grade or more point to this assignment. Thank you guys.